那么我们接下来就看这个 Day12吧，哈，那 Day12最后一天应该是最重磅的发布了。那么看这个气势啊，应该是蛮重磅的哈。这个老板啊 ，CEO 啊 ，Sam Altman 终于又出来了。那么他来领头来介绍这个 OpenAI 最重磅的 O3模型。那么我们来看一下啊。由于我开了这个中英文呢自动的字幕工具哈，所以大家也可以跟着我们来一起看。
How much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. Got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at OpenAI. And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweetBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this context coding site called Codeforce is about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once.
All right.
So I'm safe. But yeah, really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is Epic AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to
These are extremely hard.
Yeah, very, very hard problems. Even Turnstile says, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Camrad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to that.
Thank you so much. Yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But the work also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ARC AGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know, it's also a benchmark that we've been targeting, been on our mind for a very long time. So we're excited to work with you in the future.
Worth mentioning that we target and we think it's an awesome benchmark. Yeah. We didn't go do specific work for this. This is just the general O3. But yeah, really appreciate the partnership. And this was a fun one to do.
Absolutely. And even though this has done so well, ARC Prize will continue in 2025. And anybody can find out more at arcprize.org.
Great. Thank you so much for coming on.
Absolutely.
Yeah. Okay, so next up we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about. And
所以看到这里，各位观众朋友应该知道了，所以 O3的这个发布啊，OpenAI O3的这个发布啊，全靠一堆评分图表，那么再加上这么一个叫 ArcPrice 的这么一个第三方AI 评测机构来发布，它连个像样的 demo 都没有给大家演示，这个事情简直我觉得没这么离谱的发布会啊，你好歹你哪怕说这个模型很大很重，你好歹也实时互动的跟大家演示一遍吧。不，我不给你演示，再见，我就给你看点评分，这个一点诚意都没有啊！我觉得就连评价的语言都没有了，就没有任何诚意啊，简直不可理喻啊，不可理喻。当然，让人更生气的其实还在下面哈，这个 O3 mini 的这个功能的演示啊，那简直现场就有点炸裂哈。既然我相信大家多数还都是蛮关心这个 OpenAI 进一步的发展的，所以我们还是把这个事情啊跟大家一起耐着性子给它看下去啊，这样比较好一些。
about and Hongyu, who trained the model, will come out and join us.
Hey, how are you?
Hey.
Hi everyone, I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released O1 Mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of O3 Mini. So on the left-hand side, we show the coding evals. So it's like code forces ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have increasing ELO, all outperforming O1 Mini. And with median thinking time, it's able to measure even better than O1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's the O3 Mini High is still a couple 100 points away from Mark, it's not far. It's better than me probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code forces ELO trade-off. So it's pretty clear that O3 Mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, compared with better performance than O1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On O3 Mini. And hopefully you can test out all the 3 different low, medium, high thinking time of the model. So let me paste the prompt. So I'm testing out O3 Mini High first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call O3 Mini API, and O3 Mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great! We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number. Submit. So it's sending the request to O3 mini medium, so it should be pretty fast, right? So on this
41.
terminal, yeah, 41. That's the magic number, right? So it saves the generated code to this like local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate O3 mini with the low reasoning effort on this hard GPQA data set. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the O3 mini with low reasoning effort. Yeah, let's see how it goes.
I guess two tasks are really hard here.
Yeah, the long tail is often the problem.
Go, go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Okay.
It's 61.62%, right?
Amazing.
62%, right?
Cool,
With a low reasoning effort model, and it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to like just ask a model to evaluate itself like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
那我们在这儿暂停一下哈。那么他们现在演示这些东西啊，就到底跟 AI 的能力有什么关系吗？这应该说是一些功能啊，这些功能用代码来实现都没有什么什么难度可言哈。那它这是在演示什么？这演示的这个 O3 的 mini 版好用吗？没有，完全看不到。几个人在这儿玩一些无聊的东西，是因为这个 O3 的这个OpenAI ChatGPT O3 的这个模型是完全不可见人吗？我们也不知道。那么为什么停在这儿呢？Sam Altman 说，maybe not。为什么？就自己评估自己，自己训练自己。那么这个事情到底是他可能有不同意见哈。那看起来啊，这样一个发布会挺真实的，但是东西呢，大家关心的那个 AI 的能力在哪里呢？完全就是在搞一些不着调的事情啊，就不可理喻啊，不可理喻。
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 dataset, O3 mini low achieves comparable performance with O1 mini, and O3 mini medium achieves like comparable better performance than O1 if we check the solid bar, which are passive ones. and we can further push the performance with O3 mini high, right? And on the right-hand side plot, when we measure the latency on this like anonymized O1 preview traffic, we show that O3 mini low drastically reduced the latency of O1 mini, right? Almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And O3 mini median is like half the latency of O1.
Got it.
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on O mini series models. And here, O3 mini will support all these features, same as O1. And notably, it achieves like comparable, better performance than 4o on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually O3 mini though is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right. Next time we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah. So with that, that's it for O3 mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah. Thank you
really
so much.
great work on you.
Thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. Great. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user is trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both
Yeah,
at the same time.
it is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage leverage reasoning to get better safety performance.
Yeah, I think this is a really great result of safety.
Yeah, fantastic.
Okay, so to sum this up, O3 mini and O3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch O3 mini around the end of January and full O3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas.
Merry Christmas.
所以这第12天发布了个什么鬼啊？最后这一段呢，用图表的测试分的方式啊，告诉大家说这个OpenAI O3 mini 数学能力也挺强，其他能力也挺强。最后说安全也很重要，我们要控制好安全边界。那么既安全又能够更多的回答问题，那么这个不容易。 如果说它不是 OpenAI 已经发布了这么已经基本上可以说2周年了嘛，那我们甚至怀疑这个产品存不存在啊？这个东西这个发布会，我们都怀疑这个 OpenAI 存不存在？有 O3 吗？有 O3 mini 吗？存在这个产品吗？不清楚啊。实际上，我们从发布会的这么多个现场啊，也能够看出来很多事情了。那么首先这个 OpenAI 现在剩下这个团队啊，连这个嘴皮子利索的发布人员都不多了，能够把事情讲得很明白。这一个版本的 AI 到底强在哪里，比上个版本强在哪里的人都没有了。OpenAI 的团队已经碎了、散了、废了。而 Sam 呢 ，Sam 其实一看呢就俩眼发直啊，晕乎乎的。我们觉得说他是不是根本就对 AI 技术完全一窍不通啊？所以呢，现在什么状态呢？OpenAI 公司处于无人驾驶状态，它没有一个有足够的技术统治力的人啊，能够领导整个公司的技术向前不断发展。那么 OpenAI 其实已经完蛋了，我真的不知道它还能怎么样哈。那当然，真正最终的结论还得看真家伙。等它的 O3 模型发布之后，我们来看看啊。那么行业里边专业的人士对它的测试效果究竟是什么样子的？前11天发布的功能，我们可以简单来说，就没啥鸟用处，包括 Sora 在内。那么第12天吹了个泡，这个泡又不可见，究竟如何呢？OpenAI 会不会就在2025年上半年就轰然倒塌了呢？那么正好吧，就用圣诞快乐说这个圣诞快乐吧。哎呀，感谢您耐心的收看吧。关于 OpenAI，我们这期就先说到这里，我们下期见，谢谢。